In the last lesson we looked at the current in a series circuit, and now we're going to have a look at the electrical potential difference in the circuit. Now let's supposing that I close this switch here, and we know that the current will flow from the positive terminal of the battery to the negative terminal. It will flow in this case in an anti-clockwise direction, and as it does so it will pass around that circuit. Now in these ideal circuit diagrams, no energy is lost by the current as it passes around the connectors, okay, these connecting cables, but all of the energy will be lost through this light bulb here. These are light bulbs, okay, and then the current flows back to the negative terminal. Now let's supposing that we have a battery of 9 volts, and let's think about the electrical potential, not the electrical potential difference, but the electrical potential at different points in the circuit. We know that the positive terminal of the battery is assigned an electrical potential of 9 volts, okay, there we go, while the negative terminal is assigned an electrical potential of 0 volts. Let's ask ourselves a question, for example, what would be the electrical potential, for example, at that point in the circuit? Well, we have a look at this. If it's 9 volts here, well, there's nowhere along here where the current can lose energy. This is a perfect connecting wire. Okay, there's nowhere that can lose energy, so it must still have the same electrical potential energy. So its potential will be 9 volts here. And likewise, if we come right the way around to this point there, then the electrical potential at the light bulb will be 9 volts. Now, looking at the other side, we have a 0 potential energy at the negative terminal, where there's nothing between the negative terminal, for example, and this point in the circuit. Okay, again, there's nowhere as the current flows along this part of the circuit where energy can be lost or gained by the current. So if the electrical potential at that point of the circuit, which is always 0, if that's 0 here, then the electrical potential will be 0 volts here. So if I want to measure the electrical potential difference between these 2 points of the circuit, that's to say the EPD across this light bulb, then I will need a device called a voltmeter. Whereas an ammeter will be connected in series in the circuit, while a voltmeter is connected in parallel, and we'll have a look at what that means in the next unit. Okay, so we can say that this voltmeter will be connected in parallel, and it will measure the difference in electrical potential between these 2 points. And we can see that here the potential is 9 volts, and here the potential is 0 volts. Then the reading on the voltmeter will be 9 volts. Now what happens when we add an extra light bulb to the circuit? Again, the same applies. We remember we have a 9 volt here and we have 0 volts here. Okay, we close the circuit, electric current flows, and we know around here there's nothing to change the potential energy of the current. So this will have 9 volts at that point, and again here the electrical potential will be 0 volts here. So we know that all of the energy of the current is lost going between that point and that point. Now as these light bulbs are identical, okay, they're exactly the same, so they have exactly the same resistance, then exactly half the energy will be lost going across this light bulb as it is going across this bulb. So we know that at this point in the circuit the electrical potential of the current will become 4.5 volts. That's exactly half of 9 volts. If I take my voltmeter now and measure the electrical potential difference across this light bulb, the difference will be 9 volts minus 4.5 volts, which will give me 4.5 volts. So the reading on the voltmeter will be 4.5 volts, and likewise if I put it here, then the reading on the voltmeter will be 4.5 minus 0 volts, which will be 4.5 volts. Now what about if we look at the next circuit? Again, I've added an extra light bulb, again an identical light bulb. We've got a 9 volt battery, so we've got 9 volts here, electrical potential 0 volts here. The electrical potential here will be 9 volts, and the electrical potential here will be 0 volts. And we know now that in each light bulb, exactly a third of the energy will be lost going across each light bulb. So if it has 9 volts here, then we expect it to lose 3 volts, so its electrical potential will be 6 volts here. Again, across this light bulb will be another 3 volts, so its electrical potential here will be 3 volts. Okay, so if I come along again with my voltmeter and I measure the electrical potential difference across that light bulb, it will be 9 minus 6, which will be 3. Across this one, it will be 6 minus 3, which will be 3. And across this one, it will be 3 minus 0, which will be 3. So the electrical potential difference across each light bulb in this circuit will be 3 volts.